It is the AI revolution. I am Cody Willard. That's Bryce Smith. He works with me, the hedge fund. Bryce, we run a long only fund too now. So
we run like an asset management company now.
There you go. I was going to call it capital management, but I like the asset. That's whatever. It's all good. And John Dio, longtime, good, dear, old friend of mine. And he is old. He's older than me, about 10 years. We've known each other since college. He was late
Not
boomer.
10 years older, but something. Yeah.
Yeah. I'm rounding. It's a rounding error. John.
Okay.
Anyway, John Dio, follow him on Twitter, etc. John's been working in the AI revolution world for 30 years. He hates it when I say that, but it's a great credibility builder when we mention that at the top here. So, and look, Bryce and I have been studying, I've been studying AI off and on for probably 10 years. And the last 2 years, 2.5 years since the ChatGPT moment happened in November 22. We've been Bryce, you found a text I sent you that you shared with our subscribers maybe 6 months ago now, but you found the text I sent, and you sent me a text, the ChatGPT moment day, November 22. And you're like, is this a big deal?
Yeah, no, I did. I was working at my law firm, so I wasn't in the weeds of tech. Yeah. I was like, I heard about the news, and like what I heard, what I remember, I think I said in the text was like, people say this is a Google killer. And so I asked Cody what he's thought, and his response was, have you not read anything I've been writing for the last month?
So apparently I had already been like, this shit changes everything. Yeah. But I will tell you, one of the things that I'm coming back to often as an investor in revolutions, technological revolutions, which is what I've been doing for 30 years. And, we have a long track record of buying multi-trillion-dollar businesses when they're worth billions, 10 billion maybe. Apple at 30 cents, NVIDIA at 70 cents, split adjusted prices, Bitcoin at 100, et cetera. And what I'm coming back to with the AI revolution, we'll hit some news here in a minute, but let's sort of lay some groundwork for just sort of, we published an article on Trading with Cody today talking about this concept that seems like everyone's expecting diminishing returns from the accelerating CapEx that these hyperscalers are doing. They're spending hundreds of billions of dollars each over the course of the last year and a half, 2 years, and the next 2 to 3 years. And Microsoft, Meta, Tesla, Google, Amazon are probably the main five, but Oracle also. These companies are spending hundreds of billions of dollars each, collectively trillions of dollars. But instead of diminishing returns, we're finding accelerating returns. It seems that pattern recognition, which is what human beings do to be intelligent, and what AI infrastructure is doing to purportedly be intelligence, or at least to make it seem like we're interacting with intelligence, it's pattern recognition. You used to recognize letters, and then they were like, oh, probabilistically, these letters will turn into a word, and we can predict what those words are. And then it became, hey, we can predict what words are going to be probabilistically come after each other. So now we can make sentences and paragraphs. And now we've gotten to the point where we can do deep research and we can make mostly lifelike video from just text prompts. And so, John, talk a little bit, if you would, about this. In the last 2.5 years since the ChatGPT moment, is artificial intelligence getting more intelligent more quickly than it was?
Yes. Okay. So that's
Next question. No, elaborate a little.
Okay. No. So like, just look at how we went from OpenAI had a thing called O1, and then they couldn't call anything O2 for trademark reasons. Some British product, right?
Movie theater, or a big concert venue and a telecom company.
A telecom company was the issue. So anyway, O3 came right after O1. O3 came 3 months after O1. So they had the next kind of level of capability, which was a huge jump, came just 3 months off after the previous one, when before that one came about a year after the one before it. So we're accelerating.
Like everything else OpenAI does, it's all convoluted and fucked up. So can you please explain how they changed? It was like the first ChatGPT we got was actually like 2.5.
Out in the world, there was 2.0.
Okay, and
then ChatGPT was 3.5. I invented a product off of Chat 3.0 before 3.5 hit, and then that's the way I remember it.
When we refer to the ChatGPT moment, we're referring to 3.5 when it came out for the public. That's when everybody holy shit.
So 2 years ago, and in that time we went from 3.5 to 4 to the 01 to the 03. And if you saw the stuff, the dots are getting closer and the line that they're on is getting steeper. So here's capability going like this. And along there, here's like stuff being certain distance apart, still kind of far apart, and then getting tighter together as it's on that more capability. I was drawing a graph.
I saw that. Let Bryce stop in here. He's got a comment or a question for you.
What I was going to say is something I learned recently to help me is that there are underlying models, right? And that's like what you're talking about. Like OpenAI was building models. They had a 1 and a 2 and a 3 and whatever. And then eventually they've released ChatGPT, the app, right? And then that's why we call it the ChatGPT moment, is because they built this app on top of their, what you just said, 3.5.
Yeah, the LLM.
The convergence of the fact that there's an interface that people can use and that the model's good enough at that point.
The app was the interface to the LLM.
Yeah, so the app, that interface, along with it hitting a level of capability, which kind of came together, made that moment.
Go ahead.
And like all of these, like Claude exists, and then they changed the model. Like they just rolled out Sonnet 3.7, right? So it's kind of like when you get a software update for your phone, right? You get a new iOS 18.3 or whatever. You're still using the same iPhone, but the software keeps getting better and better underneath.
Yeah, or an auto driving update. Yeah.
Yeah, same with your Tesla FSD if you're familiar with that.
John, one of the things that part of this logic that I'm at least trying to put together, because I'm not sure I've got it all logically fit together in some sort of context here, but we go from letters to words to deep research to coding to video generation,
music.
And it's like now we're getting to the point where the AI pattern recognition machines inside the infrastructure of it all, NVIDIA's Blackwell clustered together 200,000 units at Llama Meta.
Is that right?
It's getting to the point where it's now learning to recognize patterns in the physical world and then predicting what the most likely scenario that human being walking towards that building is about to do, or what that car, in the case of Tesla full self-driving, what that car turning at the red light is most likely to do relative to my car, my Tesla Cybertruck, at the perpendicular stoplight, green light.
So like, it's interesting to see, in order to get a sense for, a good picture of what it can do, is to also see what it can't do. And I saw this really good video the other day of this person talking about how you can't get the language model, you can't get it to put out a picture of a wine glass filled to the brim. You can ask for it and it'll say, "Oh, I'm sorry, that wasn't to the brim. Now I'll really fill it to the brim." And it comes back, same picture again, like the half full wine glass, over and over, whatever. And it's always saying that it's doing it. And I get you now, boy, this one's going to spill all over.
Doesn't that remind you though? I mean, that truly, when I first started using ChatGPT in November 22, that was sometimes you'd be like, "Hey, explain what 2 + 2 = 4. What does 2 + 2 equal?" And be like 3.5. And you're like, "No, dude, it's 4." It's like, "You're right. All right, show me the math." it equals 3.5. You're like, no, it's a 4. And so, but the point being that, again, it used to be very rudimentary, and 2 + 2 = 4 was too rudimentary. But
now it's so good at math.
It's very rudimentary, and now it's like trying to make a picture of a wine glass filled to the brim, which is again in 18 months, 2 years, 2.5 years of this investment in AI, we're going from it just not even barely being able to do math to now Grok can make video games based on your text prompts.
Yeah. So here's why, or here's what I think is going on. You talk about the importance of data on the side of text and everything ever written down, the entire internet worth of text and every book ever written and all that kind of thing. It's got it, and it has it available to it to make use of. Now, it's still a stochastic engine, meaning like it's operating off of statistically probabilities. It's like it can give back anything, but whatever it gives back has to be within the range of things that it's ever seen, at least the pieces of it, right? So the wine problem is try to go find a picture of like wine actually filled like this.
So if you asked it to do a soda glass, a glass of soda filled to the brim, it probably can, or at least get a lot closer than it could with a wine glass.
It might. What it couldn't do was when you said something like, okay, this is an orange fluid, don't worry about what it is, or it's orange juice or something, but in a wine glass, and go make it all the way to, it still can't do it. It's like, I cannot fill a wine glass. So it's related to the data that it has to work with, which says something about how it's not being fully imaginative. Like it's not piecing things together at a more abstract level of, I've got a liquid, I've got this thing, it's a container. Containers it's not like using physics when it's going and doing those things, right? So, but yeah,
it's interesting again, but it is still stochastic. What's the definition of stochastic? It's probabilistic.
Yes, probabilistic. It's using
stochastic engine. It's still going back to what I started off with that scenario. It's like we initially were like it was figuring out the most probabilistic letter to come after another letter in order to form words. Then it took that to work to paragraphs. Then we've taken it to deep research, to coding, to the physical world, to video generation, and next it's physical world robotics. And
just to get my sense of stochastic, and we talk probabilistic with sense of what it is like is you have a probability distribution. Like here's all the things that could occur. The most common is up here on a bell curve, and then it could also happen all the way out here. And it's like a dice roll, and like it's possible take a random number from 1 to 1,000 for it to end up like way out here or way out here. But most of the rolls are kind of taking you somewhere up in here. And in this case, if it's not even on there, it can't, work with that. But now that's to see that in that wine example.
This is Grok 3, the latest and greatest from XAI, and it still cannot make a
That's absolutely fascinating.
Yeah.
Still can't do it.
Now, meanwhile, you can give it math problems now that are at a level that the greatest mathematicians in the world have trouble with, and it can do it.
Exactly. That juxtaposition of geniusness in the probabilistic stochastic engine versus its inability to have any actual understanding that you could fill a wine glass to the brim.
Well, that's like right there. If you want to talk about like AGI, it's a good example of there's no common sense there. There's nothing behind what it's doing. Oh, did it do better this time?
Yeah, he has to do a glass of soda.
Soda. Yeah.
Which that more looks like.
I was about to say that's lemonade and iced tea, but whatever.
But you do a beer and you'll see it all the way up. It might be Sprite. No, you're right. So
the reason we don't fill wine glasses all the way to the brim is so that we can let the wine breathe a little bit.
I imagine so. And maybe it feels the same. Maybe it feels the same way about that. It's like, no, that would be gauche.
Gauche. Oh, nice word. John's always throwing out some good vocabulary for people.
I'm not going to do that.
That's a one-syllable college word.
So
hey, you know what I looked up today? driving back from Las Cruces right now with my wife. The song Apata, 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 You might not know this song, John, because your daughter's already off in the real world. But if you have an 11-year-old, you know the song by Bruno Mars and some other lady from Korea. And I was like, hey, Apata is just short for apartment, right? Like you're just saying, meet me at my apartment. I said, I don't know if that's true or not. So then I Googled it, I looked it up, and I was like, definition of Apata, APT. And it was like, it means very succinct and to the point, something that would
no, that's called apt.
Well. And then I was like, I think they meant apt. I think that's, it just gave me.
But if it's the Korean in the in the song who's doing it, they might be. That's
for the record, actually, what it does mean, it's a
syllables.
Drinking game. It's a drinking game in Korea called Apata, and then they sort of did make it funny and like me, like.
You see, this is also comes from like where the data comes from. You can't say apt in Korean. You can only say apata because it's a language that uses consonant vowel, consonant vowel, consonant vowel.
How do you know that? How the fuck do you know what Korean language?
I know the Korean alphabet. I know I can write things in Korean.
I quit. Like you talk to John every freaking time. He throws out something that you're like, wait, why do you know the Korean alphabet, John?
I'm looking for my Korean.
The pattern recognition. So John, you can recognize the patterns of lines and circles put together next to each other and say, that's actually the Korean alphabet.
Yes.
But I can recognize the pattern that I'm 99% of the time, I can tell you whether it's Korean or Chinese or Japanese. I can tell the nuanced difference between them. Whereas like my wife, who, lived in rural New Mexico most of her life, doesn't have the pattern recognition background to recognize that's Vietnamese and not Korean.
Yeah. I can't write Chinese. I can only write Korean and Japanese.
Who says something like that? Bryce.
It's just a hobby. It's like something I'm interested in.
I quit. All right.
I've been interested in
John is a fucking AI. John is a simulation. Bryce, you have a question? I got some too.
No, I wasn't going to ask a question, so go ahead.
My question is this, John. I've been digging in, as always, on other companies trying to use LLMs and AI and build other products. Autodesk is a recent purchase for us and the funds.
I can't believe they're still around. They've been around since the 80s.
Correct. Autodesk. They make AutoCAD. And so even in college, when I was an engineering student, we used a very rudimentary old version of AutoCAD. And nowadays it's advanced tremendously. And nowadays they're using AI to make the designs and the abilities in that AutoCAD program ever better. Mm-hmm. They just helped make a part inside of a Boeing Airbus, an Airbus part, like 85% lighter by creating Boeing that nobody had ever thought you could do before. It's just as strong, but it was totally doesn't have as much mass as it used to. They talk about making a frontier model. They've built a frontier model inside of AutoCAD. Autodesk has built a frontier model inside of AutoCAD to make their designs happen more quickly. If you're a designer and engineer, like, hey, I want to make a new car, let's design it like that. It gives you a base. It gets you started. What kind of car are you looking for? No. And then you can just tweak and make it better and you can interact with it. The question I'm getting at is a frontier model always built on top of an LLM? And an LLM is a large language model, which is what we started with initially. So talk to me, compare and contrast a frontier model at Autodesk versus an LLM making Cora work.
And I'm going to be, slightly more informed maybe on this, but I'm not. This isn't like the final answer or something.
It's not blind leading blind, but it's someone with bad eyesight leading.
The slightly sighted leading the blind. So anyway, no, the LLM is a frontier model. First off. And the one from Autodesk, what I'm hearing you say that, and it's interesting because nowadays, you would say you have a frontier model like 4 Omni from GPT. When they called it O for Omni because it's the kind of the combination, I think, of visual and text, like all into one model. And for Autodesk, you know, what's really probably interesting to me was the fact that the visual stuff for them is not just like generative images. It's a whole design language of all of the kinds of
the
boxes and lines and connected things and the physics of. So for them, you know, when you're making one of these models, like when you're making one that just does images and text, you know, that's the inputs are coming together. You know, you might have like this image and some caption and stuff, and as it's getting trained on it, and that stuff's getting like read through and combined and attended to, as they say, it's happening like together. It's like looking at both things, the image, the text, and mixing. This vector is made up of information that has to do both with that image and with that text kind of thing. Well, for them now, it's more than, you know, image and text. It's text and design pattern thing, piece of whatever, so that, you know, rectangles and lines and arcs and size information and all these kinds of things are so related to that you could kind of talk in what you want to have happen.
I've asked you before to sort of walk us through, and again, I'm sort of seem to be getting back to this concept of, I'm trying to get how we went from leaping from making words probabilistically to making paragraphs probabilistically, to making research, to making coding, to making video, to now making unique designs for Airbus in the physical world. And it still is stochastic engine, but where does LLM stop and Autodesk frontier model start?
So there's a couple of
and one last question actually on that. Isn't Autodesk using the LLMs somewhere in order to even have the text prompt engagement?
I believe that if they are making a frontier model, that they are making their own LLM. And so they're taking, like what's done with, you know, Meta, and some of these things you now I think can, you know, not totally start from scratch, but they may be starting sort of from scratch in, you know, following the recipe of, we've got a bunch of content to work with and we're going to go make this thing. But that's part of what they're doing probably.
And they would have, they're not building a data center. They're going to like Amazon Web Services and being like, yeah, we'll rent out a bunch of GPU, LLM,
whatever. You know, it doesn't matter. Whatever works for them at that level.
But they go to a hyperscaler who has NVIDIA GPU compute that they can then train. They lease the compute power from a hyperscaler and train it to their own.
I was going to take you through these couple of paths, right? Yes, the answer is yes. And it's, you know, there's the piece that goes like from word to sentence to paragraph to page and so forth. That end of things, I could say if I'm saying an LLM, you know, give me a 10-page paper that talks about blah, 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 write a book. If I'm using maybe Google's with 1 million context, you know, a lot of room to work, you know, hand me back this big, long thing. All of that is still one character at a time. And so you can think of it as atoms made of molecules made of, you know, or other way around, atoms that make up molecules make up some material and so forth, and it builds on it, right? But at the lowest level, that's still occurring in there. There are a couple of them coming out now that operate at a slightly higher chunking level, but that's kind of still going on. But that's just along the path of, you know, what pieces together from word to sentence to paragraph to page, etc. But now when you talk about other stuff like images and music and the vectors that make up what Autodesk is doing, now you're talking about a different thing, which is they started to learn how to do that melding together of the data. You know, even if it's image data, you can make it sequential. You know, if you make a JPEG or a PNG or, you know, some kind of image file that you're going to go and take, you know, inside there is just a bunch of serial data in a straight line, a bunch of zeros and ones. And they can take, you know, at whatever low level and treat that like language, like stuff that's right along with the English that they're feeding in. As long as what happens at the other end is you called it, the stochastic output, that you're getting back out like stuff like what you put in. So that's just more, it's just more data. It's structured data. There's a structure to it, and if there's a structure to it, that's what language is like. Language is more complex, but
and even intelligence is structured. Bryce,
John, I guess what I thought was happening, and I think what you're saying changes that, is like in my mind, Autodesk was working on a certain modality of AI, being this CAD, just the CAD part of it, computer automated design or assisted design. Then I thought they could take LLMs, which they don't have to reinvent the wheel on that. They could just plug that in somehow, the text modality, and plug it in with the CAD modality and make them work together. But what you're saying now is you think they probably did their own language.
Yeah.
What do you call it now? NLP, natural language processing.
Well, it's much more than NLP at this point, but it's what's happening more is, and especially when you I don't know what they're doing, but you say they have a foundation model. I believe that they're not inventing the wheel. They're building the wheel that's been invented. They have a recipe for the wheel. So going and making how come we have so many open source LLMs out there, like tons? You get on Hugging Face and there's this big explosion of LLMs, right? It's because people learned from each other how to put that wheel together. And that's the question is, at what level are they getting in? And then the other thing is that some of them are making like an adjustable wheel, like from Mixtral, where you've got, the 8 different pieces of it all coming together, and I'm just going to peel out one piece and stick in another one. It's like how much you are from scratch in putting that wheel together. I don't know, but I do think it's lower level than them taking 2 separate models. Like here's my text one and here's my, thing. If they're making a foundation model, I think they're building those more together.
John, you're using the term foundation model. I called it frontier model because that's what the literature I was reading called it. What are those the same thing?
I don't know. I think that the difference could be, if you said a frontier model, I would think you're talking about like the one that's at the edge of capability. Like no one has one that does this kind
and
of
a foundation model would be just something that's like built at a very basic level.
Well, the foundation model is like the one you get from doing pre-training before you go through the other steps, the RLHF and stuff to go, finish it off, the human feedback loop that, for improving it and stuff. So I think that's what, yeah.
Bryce, do you have another question? You might want to fix your hat. We pulled it back, pushed it back.
Oh, I like it.
Yeah, Bryce, your hat.
Yeah, you want it? What do you want? It more forward?
Usually it's down a little bit. I don't know.
Okay, I think that says more about you than
Bryce is going to love this.
No, now he's going to freak out when he looks up and sees what you did now.
Yeah. Oh hell yeah! But Rally Cat, Bryce, put it inside out, man. Tomorrow morning, if the market's down, put that hat inside out.
Did I mention that my nephew's on the Red Sox now? Okay, just now you mentioned.
Yeah, you mean I almost really gave you a hard time.
I know you say it every time, but so he got up in his first. By
the way, he's the New Mexico AD's son. Bryce, you would love this. Alex Bregman, who's our Bregman politician, going to be mayor sometime.
He's the district attorney now for Albuquerque.
He's going to run for mayor.
Years ago, he just
governor. He's running for governor again. I think he's got his son's credentials to lean on.
He keeps getting involved in politics, but so
why are you bringing up Alex Bregman at all except to brag? Was there
you talked about the rally cap, and that gave me a chance to brag. I was just going to let me get out one thing, which is in his first.
I don't think we're going to let you. No,
his first spring training.
I got a question. No, we don't care.
It'll be the answer to my next. It'll be my next answer to the next question, whatever it is. So, in his first spring training game, he's 3 for 3 and got a home run. There you go.
And it's not even a real game. It doesn't matter.
It took less time to It took less time to say it than it did for you to complain about it.
But nobody cares about the guy who used to play for the cheating Astros. John, speaking of cheating, segueing that into the topic here, AI versus crypto. Bryce and I, somewhere late last week, I don't know, he said it or I said it. At some point, we were like, you notice how there's nothing ever new and exciting coming out of blockchain and crypto. We've been waiting for 10 years, 15 years for any real world, mainstream service application, business, something to be built on blockchain. Meanwhile, Amazon partnered with Home Depot 5 years ago for supply chain, blockchain bullshit. It was bullshit. Never happened. Microsoft did something with somebody at some point. Nothing happened. We have no mainstream blockchain crypto service application or business. And every freaking day, you and I and John and Bryce see something on Twitter, or we're using something that's AI generated. And we're like, oh my God, the world is changing forever. So, John, I just wonder, do you, blockchain, like, can you finish that statement? Blockchain versus AI?
It sounds a lot like fusion. We've been talking about it for 40 years, and it's always like the big breakthrough just happened, and now it's going to come in only 10 years, which would have been 30. And another big breakthrough happens, and now it'll come in 10 years, which would have been 30. It's like nothing changed. We're still,
Bryce, what are the great breakthroughs in crypto and blockchain over the last 5 years?
It's all, although there are none, but the news is always bad news. It's always fraud, another fraud, another scam. Like
the breakthrough is going from NFT to meme coins.
Yeah,
but it's still just grift. It's all just scams and grifts.
Yeah, and you should clarify that besides, like, Bitcoin is the original use case for blockchain and remains basically the only legitimate use case for blockchain.
Which we, by the way, are big believers in Bitcoin. I've been in Bitcoin, like I mentioned earlier, for 11, 12 years now. I'm a believer in the Bitcoin open ledger, transparent, verified by millions of servers business model for currency, for one currency to compete against the US dollar. That would be Bitcoin. For full disclosure, we have been and remain short Ethereum, and if we could short Solana, it would be our biggest position.
Do you think that Bitcoin over the years has reduced in volatility?
Yeah, absolutely. That's verifiable.
Okay.
I think somewhere on the scale between AI breakthroughs and crypto grifting is the quantum stuff, right? Because there is legitimate stuff happening in quantum computing. The big tech companies are working on it,
but it's pretty
cool.
There's
also a lot of grift happening in quantum. And then this last week, Microsoft rolled out a new quantum chip, and they said they discovered a new type of matter, like you learned in college or in high school. There's solid liquid gas. They said there's this new kind that we invented. Okay,
they didn't invent it.
This is the paper, and I read this paper last week, and I was like, "Holy shit, Cody! This is some interesting stuff."
They didn't invent it.
Wait, hold on, John. Let him finish.
I just want to tell this story because I'm like, we're short Microsoft as a hedge, and so I'm like, man, rethinking that and what we should do, and we're like, nah, we'll stick with it. And then this week, I want to see what's going on with the Microsoft stuff, and it turns out that most of the top physicists that have reviewed Microsoft's open source paper where they invented a new type of matter called bullshit. And then it turns out that Microsoft pulled the same stunt in 2019, and they actually had to retract all of their research that they published back then because it didn't turn out to be true. And then when they did it again, they're already facing a lot of criticism from the scientific community.
They haven't retracted on the new stuff yet, right?
Not yet.
It's been 48 hours, John. Give them a week.
Well, yeah, but they're getting, more productive about their retractions. No. So, first of all, we should have caught on to something right when they said they invented a state of matter, because I don't think you can invent states of matter. You can only discover them. It's somewhere out there. It's like we hadn't seen it before, kind of thing. But inventing
that might be Bryce's wording, not theirs.
No, it is theirs. They said invented.
They literally said they invent. Oh my God.
Yeah. So I mean,
well, I'm glad you guys sort of segued us to Microsoft, because that was one of the things I wrote down to talk about today. We've been talking since the first AI call with you, John, 8 months ago, 10 months ago, a year ago. I don't know how long we've been doing this off and on every Monday, but we've been very skeptical about Microsoft's approach with OpenAI, where Microsoft is just sort of like, hey, we're going to let you build the LLMs and the frontier models at OpenAI, and you can we'll give you money, and you give us that money back in the form of paying for our cloud and compute services, and we will make Copilot and other agents and applications built upon your LLMs and frontier models. And you fast forward to today, and OpenAI is releasing its own agents and applications built upon their LLM and frontier model. And it has been a slow motion unwinding of this partnership that's been going on for at least 6 months or a year.
Yeah.
And it feels like it's accelerating. The fallout, the breakup it's almost like really already happened, and now they're just got to go to divorce court or something.
Well, they just pulled out their, what is it, 80 billion out of the Stargate thing, right?
They didn't quite pull it out, but they're like, we're going to reallocate some of it to the left instead of to the right.
Okay.
But the deal, what John and I were talking about before was that like, what's the implications for NVIDIA, the whole AI spending cycle that's happening here? And I mean, we don't think, and Cody, you talk about this more, but like, we don't think there's a very good read through on what's happening at Microsoft with OpenAI and their spending versus what's Google and Amazon and Tesla and Meta.
It completely, Google, Amazon, Tesla, Facebook, Meta, I call it Llama now. They changed their name from Facebook to Meta. I will not call it Meta. I'm going straight to Llama. So Llama and the rest of these guys, what is happening between Microsoft and OpenAI is meaningless to them. They don't care that Microsoft screwed up the entire AI revolution and Microsoft's place in it. The rest of these hyperscalers not named Microsoft are continuing to accelerate their spend. And let's throw on the fact that this afternoon, Tim Cook over at Apple, as Trump would call him, Timmy Apple, he was visiting Trump last week, and in order to kiss the ring, he was like, tell you what, we'll spend $500 billion in the United States on technology and employment and other things, including building a new factory that will what, Bryce?
They're going to build servers for Apple Intelligence.
And what would those servers probably have inside of them?
Probably NVIDIA chips.
For the record, Bryce and I have not discussed this yet. This is us discussing this in real time.
Do you think so? Apple will use NVIDIA for that?
What's that?
There's a chance.
Apple will use NVIDIA for that, you say?
We don't know they did not make that explicit in the announcement, but unless Apple has secretly created training and inference chips that are more cost effective on a per energy unit than the NVIDIA Blackwell or any H200s or any NVIDIA chips, which for now remain by far the most energy efficient training and inference chips that you can use.
Yeah.
You got to assume they're going to use NVIDIA chips, but
they have a relationship already?
Ish.
Yeah, I think there is some bad blood way back in the day between maybe even Steve Jobs and NVIDIA. I think Apple and Mac computers don't have NVIDIA graphics cards in them.
They don't have any graphics, Queen. They have a graphics processor that's part of their, integrated into the same chip kind of thing.
Yeah.
But yeah, that's one kind of sore point with the Mac is you can't like shove a card in there for your graphics.
Hey, Bryce, can you make a note next Monday on the OpenAI call? I want you to talk about that paper you wrote for Trading with Cody last week, which was talking about why GPUs and linear, what's the phrasing?
Sequential versus parallel processing.
Sequential versus parallel processing, and why AI exists, because NVIDIA tapped into the importance of parallel processing versus sequential processing.
Yeah, serial versus
let's
parallel.
not do that today because we're already 40 minutes into it and we're already deep down in the weeds.
Right, Bryce, that'll be serial versus parallel.
Yeah,
is what they call it.
Okay.
So
but don't go there yet, John. We're not going there yet.
They got back in it for gaming. I mean, that's when they really got right, and then they ended up going down. Yeah.
I don't think you're giving Jensen enough credit. I don't think it was an accident. I think he's had a grand vision this whole time to get us here.
He says no.
I don't believe him.
Okay, now it's you. You don't believe him. Okay, so
yeah,
I'm the one supporting him.
I can infer pattern recognition enough to know he probably actually had a plan the whole time.
What he and no one knew was the way AI would take off, and that's the thing that happened. So
yeah. Any questions from the people watching, comments, etc.? What do we got here? What do you think about AI's decision-making ability using pattern recognition? You talked. I mean, that's not sure. It is. Go ahead.
We talked about a couple of kind of paths that it's on to improvement, and one I didn't mention, but really is important for what you're asking here, is what they're calling reasoning. And these latest versions, like the latest version that's out from Anthropic, Sonnet 3.7, the two latest versions from OpenAI, they are doing chain of thought reasoning. They've taken it, instead of it just being like you ask a question, it gives an answer. Instead, you ask a question and it goes through thinking, and you can see it's thinking, and it goes, maybe it's this and maybe it's that, and I should think about whether this aspect of it, and kind of it pieces things together. And by doing that, it's just really much smarter. And also an important aspect of that we talked a little about last week. We call it like, there's the creating that model in the first place kind of thing, which handles supporting of that, just ask a question, get an answer. But then there's the test time compute or inference compute, which is this thinking that goes on. And that thinking that goes on, the more you do of it, the smarter it is. And that can happen at the time you're asking the question. So that's what's new in the last 6 months, is this whole way that the answer takes place, and the kind of inference that it's able to use, and the compute that it can rely on changes the game somewhat for the chips and what opportunities there are for those chips.
Do you know why, John, that if you let the test time compute, or whatever, the part after, I think that's the right term, right?
Test time, yeah.
Why, if you say, okay, GPT, I need an answer right now, it says, okay, here's the answer. But then you say, okay, I'm not going to put this time constraint on you. You can go out and think for a while and come back. What is happening underneath the surface that makes it give us a better answer if it has time to think versus if it has to spit out a response instantly? You know what I mean? Obviously, It's intuitive for humans. If I ask Cody a question and say, give me an answer tomorrow, then he's going to think it through and get a better answer versus you have to give me one on the spot. Why does that work for computers?
Two things. One is, it doesn't just simply happen because you gave it more time. They had to change the way the system works in order for the giving it more time thing to work. Now, why does giving it more time work? Because it's going through multiple steps where it's not just answering. It's not just taking the time to go hum and think a lot, right? It's taking the time to come up with a partial answer, intermediate thing. It's like, come back out with what it figured out so far, and itself kind of look that over and go, is that enough? Should I do something else here? And it's taking itself through multiple steps. So like, think of yourself doing like long division. You don't have the whole thing, figured out in advance, but a process you can go through, and you go step by step by step. And at the end of the long division, you're able to do much more difficult problem that you'd never just pop out of your brain with.
That makes sense.
It's interesting as you explain that, because even the article I wrote today, technically I came into the office yesterday and wrote it, but the article that I just wrote, I bet it's 1,100 words. And I had spent probably a week thinking about it, and I jotted down 2 or 3 little bullet points at some point, but my brain kept sort of like every day it'd be like, oh, there's another little bullet point, don't forget that. And I'm sure I forgot half of whatever I didn't want to forget. But at some point I came in and I wrote that article in 30 minutes or something. I mean, it was like already done in my head, but it was because I'd already done so much of the processing and the research slowly without even knowing I was like doing it. And that's probably sort of relates to what you were just describing.
Yeah. And I mean, I don't know, like there could be differences in how much of it ever was out loud because it happening in your head was good enough, but you were essentially carrying on a conversation in your head.
No, that's right. That's right. Do you think? Yes, I do think. Well, all right. Well, why? Well, I think this is why.
So something I did, I was working like on an article and I had a conversation with the AI about the topic. And I said, okay, like, let's go deeper into this and that and so forth and talked about it. And then when I finished, I said, all right, well, give me 1,000-page article. I'm sorry, 1,000-word article on what we talked about so far. Focus more on this aspect. You can use a code sample at a certain point, but it's going to be, you should write it toward, business people, design folks and programmers. Like it has to be at a level where all of those can understand what it's about, but go through. And this article was about multi-agent architecture and the different approaches and what could happen if you go this way versus that way. And it came out with an article and it did. I went back, read it over and I went, you're emphasizing too much on this and not enough on that. And boom. And it came out with another art, it just rewrote it and did it again. And it was.
Can you share that? Can you share that with us?
No, I can't. I could get with you guys. I guess it's not. It's internal company stuff. But I could do the kind of thing. We could do it as
Bryce has been doing that. I mean, Bryce, talk them through like what you did with Autodesk when we owned Autodesk a year ago with the same thesis that they have so much data, unique access to data about design and functionality and physics and how you build things and how many nuts and bolts go in when you build this versus that, etc. And we were like, that looks like unique data that AI is going to be able to take and accelerate and do amazing things with. And then they had an accounting issue about 6 months ago. And we have several golden rules in investing. And one of them is don't fuck with accounting if there's a cockroach run. And so we sold the accounting issue. They spent 6 months getting to the bottom of it. Sounds like it's gotten resolved. We've moved on. Came back to the stock last week. Bryce, what did you do? You went to Autodesk. You went to ChatGPT and other LLMs and prompted what?
Well, I took my original thesis and gave it to the LLMs and said, is this true? Update this. And so then I had to rewrite my article and just give it, give a fresh update. But then also I took the thesis, gave it to the deep research, deep thinking models, whatever you want to call these things, and spit out, one of those 10-page or 20-page reports. And it's like, I ask it to critique it, push back, be objective. But I also find that you have to kind of give it like your thesis. I want to deep dive on Autodesk, but I don't just want a high level overview. I want to at least give it our thesis on about like what Cody's talking about with this unique data edge. And then, analyze, critique, and tell us how that's happening. And then it actually did. And then it pulled out relevant things. And, you have to go fact check and make sure everything it says is true. But, it talked about, the senior vice president of research or whatever, and how he's talking about the data advantage and how they're using data to build generative models and things like that. So, that's
what's amazing, Bryce, is you literally, and then we shared that, by the way, with our subscribers. If you guys want it, shoot us an email, support@tradingwithcody.com. We'll send you this article we wrote last week that had links to all of the research we've been doing on this type of stuff. And what's crazy too, then, Bryce, the opposite was I wrote that article yesterday, and then today I was like, hey, can you edit it, make sure the grammar works? Because I think I saw a couple of grammar mistakes when I reread it last night. And then second of all, can you run it through a couple of LLMs and make sure I didn't make any egregious mistakes? Or another way of phrasing that, I didn't hallucinate.
Yeah, true.
Which, for people watching, the LLMs the most common problem people have with LLMs, I would think, is hallucination. It literally, the initial, like there was that case like 18 months ago where like some lawyers were like, hey, here's all of the cases we're citing for this court case, and the LLM that had created that presentation had hallucinated entire court cases. Yeah. And so it's gotten the LLMs and the AI continue to learning it better, and there's less hallucination, egregious hallucination, than there was a year and a half ago. Mm-hmm. But it is still nice. Like I still hallucinate too, right? Like I'll sometimes make up and be like, who sang that song? Was that Jerry Reed? No, it was Randy Travis. I don't know. I couldn't name you once.
So that was an interesting thing Bryce brought up that we hadn't really talked about it as we talk about the different kind of capabilities that are emerging. And it was this, deep research thing, also very recent. And it's doesn't hallucinate as much, I think, because it's taking even though the language model is built out of like everything that was ever on the web, it doesn't retain literally everything that was on the web. It's as if you had, you're doing image compression. You had this picture of these people at the beach, and then you said, okay, make that whole thing exist in 10K instead of 4 gigabytes. And it's like very fuzzy and whatever. And it's like, oh, they made the way to go back up from it and go, make it sharper, put it back.
But John, isn't that a limitation of compute? That's a limitation of compute. If compute goes, it continues, the power and the cost of per energy of compute continues to drop as the compute processors get better and escalating ever exponentially better. Eventually, they'll be able to do that on a live stream, real video in 8K of a football game, and won't have to compress it.
Okay, yes and no. Yes, it will be able to do the live stream 8K, etc. But compression is actually a fundamental necessity for intelligence. So it has to go and take stuff away in order to store essence, because like the essence of dog and of cat and of the
another way of saying, John, another way of saying it is like I read this research paper on NVIDIA, and I don't remember the words. I don't remember the verbatim of any of it, but I compress it down to, hey, what was meaningful out of there that I took away?
Now, what does meaningful mean, right? It's compressed because what meaningful means is that the essence of what was there and what you know about it. And you could kind of take, there's this example of like the Rain Man type person who can tell you every word that's in there, but who can't know what it's about.
Right.
Yeah.
So it's really important to be able for it.
So in other words, like the Rain Man in that example is the internet, and the genius who can actually do something and take context out of it would be the Leonardo da Vinci.
Yeah. If you can take Leonardo and do a like brain fuse with Rain Man, that's what you get with deep research, which is a product out of OpenAI, but Anthropic is also doing it. And who else? Google has a version of it. They had it first, maybe. And what that is this language model, which is built off of everything out there. That's how it got started at its point. You now want to talk to it. And it's like, I could talk to you about anything. But if we want to go and actually do research on that, we're going to go back to original sources, research papers. And guess what? I'm getting good enough, the model is, to understand those research papers like you are with that paper you just picked up. It's like to really understand it and to piece it together with another one and to get at what's the data within them and what's the trends of things and so forth. And the analysis that it can now do is unreal. It can do things that, like when OpenAI came out with theirs, there's somebody who works at OpenAI who said, his wife had this, I forget which exact illness, it might've been cancer. Like there was these multiple specialists who were recommending different things to do next. And he sent it off to do the research, and it came back and he showed it to those doctors, and they were like, yeah, that's a smart way to go. And it had all of the data about, that it was combining to land at that conclusion,
So, John, is it possible then that like Google is doing this with Gemini, where when you go to Gemini, you can now, there's a button you can switch and say, do you want it to be grounded with Google search? So it's trained on the internet, compresses the internet. Now it's going to spit out some tokens based on what it's trained. But now I think using RAG, retrieval augmented generation, it can go and RAG everything it does based on, again, with Google, the whole internet, right? So you've trained this model based on the internet. Now it can check its output based on the whole internet since it has access to Google search.
Yeah. And then there's one extra piece in there, which is like first round of RAG is just like free-form text that you then pull into the context. Like it's as if you typed it in or pasted it in to you're like, hey, I have this question and here's some other text to go with that question that might help you answer it. So it's fetching that stuff and putting it in there. So the next step from that is what I work with are knowledge graphs, where you're actually making structured knowledge like I used to do in the old days. And it is part of how you're pulling the stuff. We're doing things where you can ask like in ours, you can ask a detailed question about the banks with the most assets and in this thing that makes sense along with that one and are good for doing this kind of whatever. And it is turning the question into a like database query for the graph database, pulling structured information in as well as the traditional RAG kind of information, putting it all together, answering. It's pretty amazing.
What do you call that second piece, John? What do you just? Is there a name for that?
Yes.
He's got to go retrieve. He's got to do some RAG.
Yeah,
find that name.
That's fascinating to me because I think this has big implications for Google. That's why I'm trying to get my head wrapped.
Graph RAG is what we basically call it. Yeah, graph RAG.
John, if you come up with a different term that pops into your head when we are off this call, would you shoot us a text with the term so we can research it some more?
Yeah, I think that's the one you find stuff around if you look up graph RAG. Yeah, Microsoft had a real interesting thing that they wrote around it.
We're going to wrap this up with 2 comments from me, and then you guys can have the last words. First one is a terrible little thought process I had when you were like, instead of whatever term we were using, we're going to go with serial versus parallel processing. And serial made me think of, this is terrible, but like a serial killer versus a weapon of mass destruction. And that's sort of why the GPU can do more all at once than taking a line one at a time. A serial killer does one person at a time, where even a terrorist goes in and kills people all at once. It's a terrible analogy, but again, my brain's just trying to sort of understand the stuff and give it some context. John, thoughts?
So this doesn't count. This is not my item, but I did for when the company was doing a Halloween thing, I went as a serial killer. And I had those little cereal boxes all over me with little knives poked into them and the blood coming out of them. So that was a serial killer.
John, we don't bring you here for your humor.
Yeah, you might not anymore. So no, let me throw. Here's my last thought.
No, this is you get your last thought after my next statement.
Okay.
The last thing I was going to say is this: that I went to Las Cruces today to go to the dermatologist doctor because I live in the desert of New Mexico and I golf a lot. And so we keep once a year, we get our skin checked, our chin skeked. And I thought to myself today, like that guy looked me over, we waited 15, 20 minutes, took 5 minutes to look me over. He burned a little thing off my eye right here, my nose right here didn't burn it. He froze it off. Right. And my wife drove me and then she drove me back. And then that guy did that. And then we interacted with the support staff about billing and things like that. It's all taken care of through insurance, but we're out the door. I thought the whole time, and I think Bryce, you and I have started doing, let's just explicitly say it. Everywhere I go these days, I'm like, when will AI take that job? Even orthopedic surgeons are already using robots. Intuitive Surgical.
Intuitive.
What's it called?
Intuitive Surgical makes the Da Vinci machine.
The Da Vinci, yeah, it's going to say Leonardo. It's the Da Vinci, and they're already using that, but it is a human controlling the robot remotely.
Yeah,
and we're getting to a point though where maybe not orthopedic surgery, but burning off a few lesions, like problematic, worrisome skin spots on your body, recognizing it and burning and freezing it off. Maybe not in 2 years, but maybe in 7 years, maybe in 10 years. How long before my wife doesn't have to drive me to Las Cruces? Now, granted, I could have driven myself, but literally we took her old ICE car instead of our Teslas. It's a little long didn't want to go to the other side of town and supercharge. We needed a supercharger in between too. But the point being, I'm not going to bother driving. The doctor's not going to be there to do the checkup and then the actual procedure. And you go to the restaurant and the order taking will be AI. The server will be AI robotics. The attorney, my wife, she'll be using AI to do 80% of her work. Like, it's interesting. And I just sort of want to explicitly say, I'm starting to spend a lot of time every day thinking about how long before whoever is giving me this service, product, or application no longer has a job.
That's my topic had to do with that.
Hit it, John. Your last word.
That was my last word. Was I'm going up the same kind of end of things. Related to what you're saying, I think that the bottleneck is the physical aspect. Do you have the tools and so forth? But you could, have this centralized place that had all of what it needed to work with, and then whether it gets embodied or not, it's there's an optimist right there able to go and do that piece of whatever. No, the thing I was going to say, and I heard it from someone, I have no idea who it was, that it was a recommendation that if you're worried about AI and jobs and what's going on, like the best thing to do right now is to do what we are doing, which is interact with the tools that are available. Just start. If you're not using ChatGPT or something like it, you should start to, like, every day. Think of it the way you use Google almost every day. Just think of it like that. And there's just tons of people who aren't, even though there's 100 million, whatever, how many now?
They say 400 million monthly active users.
400 million, worldwide, out of 8 billion or whatever. So, like, people need to be using these things and to be continually looking at what are the capabilities that are showing up with it. And you don't have to be a programmer to just get in and start to do this stuff. And if you do, then I think it is true that you're not going to lose your job to AI. You're going to lose your job to someone using AI.
Right.
So be the someone
who is
using
10
AI.
times more productive than you are. That's one of the primary theses of Bryce and my new book that we are currently working on, called The Ultimate AI Book. And that idea is that, look, we're not going to lose 90% of the jobs, but 90% of the jobs are going to become 10 times more productive. And what does that do to society? What does that do to profits? What does that do to stocks? I would say, John, not only should people be using it, but as Bryce likes to say all the time, if you're worried about losing your job to AI, you better invest in the company that's building the AI that's going to take your job.
Yeah.
Bryce, last words.
Yeah, it's on the same topic, but one of the things that the Autodesk CEO said is that they view AI as lowering the learning curve to be an engineer.
Yeah.
And my thought is, when you lower the learning curve, which I think is what AI is doing across domains, whether it's engineers, orthopedic surgeon, dermatologist, hedge fund analyst, lawyering, anything, it makes it, at least until the AI like totally replaces you, which is probably ways out, it does, I think, make it easier to do those jobs. And it takes less training to be an engineer if the AI can supplement you and do much more of it. And so I think the result of that is you have maybe even more engineers and more lawyers and stuff, at least for a while, because it's now easier to do that job. It's less of a learn. I fundamentally think that's what a lower learning curve does. And so in some ways, I'm just had this thought today, but it could flip the script a little bit where we actually have a spike in some of these professions, rather than a decline because the learning curve is lower. And that's that. I'm still thinking that through, but that's my closing thought.
Amen. Flip it. So many times the conventional wisdom is backwards. All right, guys. Thank you, everybody watching. Thank you, Johnny D, for being here. Good friend as always. Old,
Thanks
but good.
Oh.
And Bryce, you're a young kid, but good. So, hey, we got some balance around here. Yeah.
All right.
Thanks, everybody. We'll see you next week. Same time, same place. We'll talk about serial versus parallel.
All righty. See ya.
Bye.
Yeah.
Thanks, Johnny.